Okay, so now we are on 2.2, just continuing these problems. I'm just going to say 2.2b. So again, the vertical line test, in case you missed it from the previous video, is a way that we can determine if something is a function by drawing vertical lines anywhere on the graph. Now, I gave a few examples. Now, even though if you draw a vertical line over here, this vertical line only crosses once. So like you might be saying, oh, well, it passes the vertical line test here, but as soon as it fails, so if you look at this vertical line, crosses more than once, twice, 3 times, this is now not a function. So in other words, it has to pass the vertical line test everywhere. Let me write that down. Everywhere. In order for it to be a function. So this linear function, vertical line passes, only crosses once. So this is a function. So if you're still confused, you could actually write out, okay, well, what's this x value? Okay, well, we only write that x value once. If we look at this x value, and this x value, they're all the same, so the x's repeat. And when the x's repeat, it is not a function. So as we look at more vertical line tests, do any x's repeat? If you draw a vertical line test, is it going to hit the graph more than once? Well, it's not, so this is a function. So I'm going to write yes for is a function. It's another linear function. There's only one way a linear function is not a function, is if it is a vertical line. That's kind of important to know. But here's a graph of a circle. Well, if I draw a vertical line, boom, it crosses twice. Therefore, it is not a function. So here's 3 more. Another linear that passes. Here's another linear that passes. This one, and you can see the vertical line right here. It fails, so it is not a function. So yes, yes, no. Hopefully this is enough examples that I can move on. So we already looked at exercise 4. Is this a function? And the quick answer is yes. And we graphed this in the previous unit. Previous notes, y equals negative x squared. So it looks like this. So if it helps to see the graph, you could see that it is a function. All right. So yesterday, or the previous video, I guess, this is why we have function notation. So anytime you see f of x or g of x, that's your clue. This is why we call it function notation, that each of these are functions. So why do we have it is now I can just write these 2 statements in the directions and then ask you lots of different questions. So now I can write less and you still understand what I'm talking about. So now what it's saying, because remember it's f of x, it's not f times x. This is not f times 1. So what it's saying is you replace 1 in this problem with x. So, and then this is telling you to go to the f function. So this is equal to 3, replace the x in the problem with 1 minus 2. And this is why in chapter 1 I made you, learn how to do this. 3 times 1 is 3, minus 2 is 1. So now, maybe I should have color-coded this a little bit better. This is telling you to go to the g function and replace x with 1. So in this problem, it's 5 times 1 squared plus 2 times 1 minus 1. And just make sure you do exponents first. 1 squared is 1, times 5 is 5. 2 times 1 is 2. So 5, 6, 7, subtracting 1 gives you 6. This is why we make you do the order of operations in that very first unit. It's very, very boring. So which function are we going to? The f function, and replace 0 in for x up here. So 3 times 0 minus 2. So 0 minus 2 is negative 2. I should be putting equal signs in here. And the reason why we have this last one, so go to the g function and put x equals -2. And a lot of students make this mistake. So make sure you're watching the videos, make sure you're listening, you're understanding that you have to do the exponent first. So this means -2 times -2, which is +4. And let me just rewrite this for now. So then multiplication goes left to right. So 5 times 4 is 20. 2 times -2 is -4. And then you add left to right. So 16 minus 1 is 15. Feel free to use a calculator, but I'm seeing a lot of people make this mistake. So make sure you understand the math. You may have also noticed I skipped exercises 5 and 6. We kind of already talked about some of those, but if you feel the need to, go back. Like I skipped these on purpose. All right. Moving on to exercise 9, I warned you in the first video that I'd be doing this type of graph later. So now I can just look at the graph and say, okay, f is the solid line. So any time I'm asking you to do f of 1, x is still equal to 1. So just go to the solid line. X is 1 right here. What's the y value? Well, this is the ordered pair 1, 0. So I hope it makes perfect sense that the y value is 0 right there. All right, I think I'm mixing up my color coding, so I'm just going to go completely different. So the g is defined as the dashed line. Well, x is still 1 right here, but now I need to go up to the dashed line, which is the ordered pair 1, 4. So this is saying what's the y value of the g function when x equals 1, and that answer is 4. I really hope this is making sense, but if it's not, please reach out to me, email, in class, whatever works for you. So now we're back to doing the solid line for f when x equals 0. Well, that's the ordered pair 0, 2. So the y value is 2 of the f function when x equals 0. And I have one more problem. This is kind of redundant though, because when you go to x is -2 up to the dash line, it's the same y value of 4. Okay, but I could ask any question I want. You know, I could ask for f of 10. You know, I could ask for g of, I don't know, -8. You know, if I was doing f of 10, here's 10. F is the solid line. 1, 2, 3, 4, 5, 6. G of -8. Okay, go to x is -8. G is the dash line. Looks like the y value is -2. So this is just being able to give me x and y coordinates, x and y coordinates. And then here's our last exercise we're going to go over. I'm going to quickly point out that these ones, I thought it would be good for you to read the graph, but we kind of already did this. Exercise 12 shows you how to use a graphing calculator. I'm not going to do these examples. I feel like we've kind of done a lot already. And then your assignment is down here, but it's also shared with you in the slides and on the Google Classroom. So go back to that. Okay, so here's Elizabeth. Purchased books for wholesale. She finds that she needs to mark up the cost by 25%. So when you're marking up a price, first of all, change this to be 0.25. What you want to do is make sure that you add that value to the original. So some teachers actually make you go through and say, take the value, let's say it's $15, timesing by 0.25, and then add the 15 back to the original. But you can actually just write this as, you know, 1x plus 0.25x is 1.25x. So this actually saves you some time. Let's write it as a function. So let's write in function notation. Maybe you want to call it m instead of f or g for markup. So m of x is equal to 1.25x. Find the retail price of the following. Well, we talked about how we could use a graphing calculator before. So let me just show you how you could do this quickly with Desmos. So just pull up desmos.com. I think we've done enough of these. You can type into y equals 1.25x. Now what I could do is I could start putting in different values for x, like x equals 15, and then go up to and see that Elizabeth needs to sell it for $18.75. Or what I could do, is what I'm going to do for the rest of them, is just pull up a table. Again, all I did is hit the wheel here, table, and then make up my own values, like 15. Was it 22.50? I already forgot what it was. No, it was 22.75. And then 38.50. And then $53. Now, I need to zoom out in order to see those ordered pairs. Let's see, this one, this one, this one. There we go. And then I would just say round to the nearest penny. So $66.25, $48.13, $28.44. Or if you want to, if you're suggesting to somebody that's trying to mark up prices, maybe always round up to make an extra cent. Oops, I was supposed to say 44. Sorry about that. 48.13. It's definitely a time saver if you know how to use a calculator. 66 1/4. And you're ready for the homework, I think. Right there.